There will be 10 problems on each test. I already posted 3 sample tests on the web on Canvas. You should look at those tests. And today I just talk about this problem by myself. But next class, if you have any questions, you can always ask me during the class. Okay. Could be the homework problems. It could be the problem from sample test. There are, well, the 10 problems, right? Definitely we have a problem on limits. We have problems about continuity of functions. We have a problem on the proofs. Give a precise proof for the limit. So the limit is already given. We also have a problem to use a definition of a derivative to find a derivative. Then other problem to find a derivatives using any formulas. Okay. And also there is a problem about the related rates. Okay. So I begin with the limit. My first problem is to find the limit as x approaches -6 from left-hand side. Here's x minus 12, x squared minus 4x minus 12. Now, you can plug 6 for x, but if you see, you get 0 in the denominator, okay? Then, yeah, actually you get 0 and over 0. Okay, so you cannot just plug the number for x to get, plug the number for x to get the limit. Okay, the function is not defined at 6. Okay, so the numerator is 0, the denominator is 0 when you plug 6 for x. That means there's a fact x minus 6 in the numerator. And also there's a fact x minus 6 in the denominator. Okay, so what you should do is you try to factor this, affect the numerator and denominator. Since you already know one of the factor, so clearly this should be 2. Then you double check. And here you should, wait a minute. No, it's not. All right, so we have, hold on, yeah. It's clear that we have a fact of x minus 6 in the denominator, okay? So this is x minus 6, but I thought that it's not 0 over 0 type, okay? So I thought I can get a factor of x minus 6. In some cases, yes. Then you look at, okay, if you put a 2 here, if you put 2 here, you're not able to get x squared minus x minus 12. So there's no, you can factor it, right? 2 and 3 and 4, I guess. Yeah, 3 and 4 if you want. Okay, so you get -4 and +3. Yeah. So we are not able to get rid of x minus 6. That's okay. We can. It's not necessary in this case. It's not to factor the numerator. So what you should write is that's a term and plus multiply by this term. Okay. To find the limit, this part, as x approaches 6 from the left, this part approaches -infinity. Okay, so as x approaches 6 from left-hand side, means x is less than 6. So x minus 6 is less than 0, approaches 0. But this part, you just plug 6 for x. So you get 6 plus 2, 6 minus 4, 6 plus 3. So it's going to be 2 times 9, and that's 8. So it's 9 over 4. It's a positive number. The first part approaches a positive number. The second part approaches negative infinity. So combined, it approaches negative infinity as x approaches 6 from left hand side. So your answer, you can go back to put the answer there, but you have to show your work. The answer is negative infinity, and then shows the details. How do you get this? Okay. Now there's a possibility you can factor this. Then you don't get an infinite limit. For example, if you want to find out x approaches, look at this problem, x squared minus 4x minus 12. Then let me put here, it's going to be x squared minus 5x minus 6. Okay. If you want to, it's a little bit difficult to compute it if you plug 6 for x, but you're still trying to factor this. Okay, and it turns out to be, here's x minus 6, right? X plus 2. Okay, then on the top, you also get 6 and x plus 1. Okay, so now you can cancel x minus 6. So you get simplified version, and you can safely define the limit. Because this, when x approaches 6 from left or from right, doesn't matter. It's going to be 6 plus 1, 6 plus 2, which is 7 over 8. So it's kind of like a misleading here. When you see, oh, x approaches 6 from left, maybe I get an infinity, right? As the limit is infinity. So actually it's not, it's a finite number. Okay? So the answer is 7 over 8. Okay, so there's 2 different type of problems you will see. We don't know which one. Okay. Yeah. Sample test is just sample set. You cannot say, oh, why you give me different problems, okay? But the sample test only tells you what kind of problems will be on the test, okay? Most of the time, we even don't change the wording. How about this, right? Only changes the function, okay? Yes. The second problem is, so we have a function, it's piecewise different function. It's x squared plus 2x minus 8x minus 2 if x less than 2, and the 1 minus cx if x greater than or equal to 2. So we want to find the value of c such that f is continuous at 2. Okay, the only trouble is 2, right? The rest of it, the function is continuous everywhere else. So this is a 2 pieces graph. There's displacement in general. So you're going to change the value c so that these 2 sides will match. Okay, then the graph is not broken, right? So by the definition, a continuous means the limit of x approaches 2. You should write down this clearly. Yeah. This is about the continuity, the definition of. When we say f is continuous at 2, if this is true, okay? If this is true, so you have to guarantee, already f of 2 is defined, right? F of 2 is going to be used the second piece, is 1 minus 2c. Okay, we know that. So we have to find the limit. But unfortunately, the limit, the function is defined piecewisely. So you can only talk about the left limit and the right limit. Okay, so right limit, this is 1 minus 2 x. Here it's going to be 1 minus 2c. Okay, this is the right-hand limit. The limit on the left, from left, we call left limit. And you have to use the other piece. Other piece is complicated. It's going to be x minus 2, x squared plus 2x minus 8. How do I find the limit? Sometimes if the limit is infinity, then it's impossible to determine the value of c. Okay, you know, if I modify the problem a little bit, but this problem, it's possible you can get a limit. Okay, when x approaches 2. So the reason is the top one is x minus 2, x plus 4. Okay, so x minus 2, x minus 2 cancelled out. So this is going to be just limit as x approaches 2 from left of x plus 4, which is 6. Okay, so the limit is 6. Therefore, first of all, we have to make sure this limit exists, right? The limit exists. Yeah, this limit exists if and only if the left-hand limit equals right-hand limit. Okay, so then c is going to be negative 5/2. Yes, but actually in this case, the limit is also equal to the value of the function. Okay, so in this case, so if c equals negative 5/2, and we know that this is going to be f of, right? It's going to be 6. Okay, so the function continues at 2. Okay, so the answer is c equals negative 5/2. First of all, you want to make sure that limit exists, but limit exists if only c is going to be negative 5/2. But when c equals negative 5/2, it's also automatically guaranteed as the limit is going to be the value function at 2, which is 6. All right, so the answer is when c equals negative 5/2, it's going to be 6. Now here is another question is, if I change the function a little bit, okay, instead of this, I change the function to just x squared for the simplicity. Now x squared minus 8, x minus 2, okay, and this is minus 2c. If x is less than 2, if x is greater than or equal to 2. For this function, no way you can find out. There's no solution. Okay? If I ask you to find the c such that f of x is continuous at 2, the answer is no solution. Why? Why no solution? Because the limit as x approaches 2 from the right hand side is going to be 1 minus 2. Okay, this is cx, not 2x. Yeah, let me go back to look at the problem. Cx, sorry. Yeah, cx. Okay, so it's going to be 2c. Okay, no problem. 2c is also equal to the value function. But if you look at x squared minus 8x minus 2, when you plug 2 for x, you see this is going to be x squared minus 8 times 1 of x minus 2. So when x approaches 2 from the left hand side, x minus 2 is negative. So this approaches negative infinity. Then 2 squared minus 8 is going to be negative. So this approaches 4 minus, it approaches negative 4. So the product approaches positive infinity. Okay? Because negative 4 times negative infinity is going to be positive infinity. So my answer here is when x approaches from left hand side, this is going to be, you have to use that piece. So answer is positive infinity. All right. So that means the limit does not exist, no matter what the value of c you choose. This one does not exist for any value of c. Okay, because one side limit is 1 minus 2c is finite, the other side is part infinity. It's broken. The graph is always broken. So the limit that's this, of course, is not going to be the value function. Okay. So that means f is always discontinuous at 2. Okay. So it will be still similar type of function, but the conclusion is could be no solutions, no value of c guarantee the functions continue. Okay, second, the third problem. Okay, prove the limit as x approaches 3, x plus 3 over 4 is going to be 1. We know the limit is 1. To prove that means you have to prove the statement. It's equivalent. Yeah, actually, this is we have to prove that for any epsilon greater than 0, there is a delta. There's a delta such that, okay, whenever x minus 3 less than delta, yeah, not equal to 0, implies x plus 4, the 3 over 4 minus 1 is less than epsilon. So if you look at this statement, you have to give me the delta, which depends on epsilon. Okay. So how to do that? There are several ways to solve the problem. Okay. You can determine the delta late. Okay. This is a assumption, right? This is the assumption. So x minus 3 less than delta is assumption. You can assume that x minus 2 less than delta. Okay. Then, under the assumption, okay, x plus 3 over 4 minus 1 is going to be, we don't know it's less than epsilon now, right? It's going to be x, hold on. Yeah. It's minus 1 minus 3. Okay. No, when x approaches 3, yeah, I think that was a typos here. The problem, this is a 1. Okay, let me change the problem here. So x3, I'm going to change it to 3 over 2, okay? Otherwise, this is wrong. 3 over 2, okay. 3 over 2, okay. So, let's combine them, right? It's 4, and that's a 3, okay? All right, so this one, since the numerator is smaller than delta, so it's smaller than delta of 4. But we want to make sure it's less than epsilon. So it's going to be less than epsilon if delta is less than or equal to 4 epsilon. So clearly, what do you have to do? We may take delta is any number but smaller than or equal to 4 epsilon. If that is true, then the above argument is always true. The left side, the inequality x minus 3 less than delta implies the right hand side is true. Okay. So then you go backward, yeah. Okay, that's one way. This is the first method. Second method is you can determine delta directly. Okay. Second method is I want to simplify this inequality. X plus 3 over 4 minus 3 over 2. Yeah, simplify this inequality. to see what we can get. After we simplified, we will get, so simple means this two equality, right? In x minus 3 less than epsilon, right? And then x minus 3 less than 4 epsilon. So the above inequality is equivalent to this simple inequality. Okay, so clearly, so this by the above argument, okay, by the above argument, I'm going to, yeah, it's, we have the following: x minus 2 less than delta. What is delta? Delta is 4 epsilon. Implies x plus 3 over 4 minus 3 over 2 less than epsilon. Okay, so we prove this. We prove the statement. We just let the delta to be 4 epsilon. That's enough. Okay. You can go backward, right? Because those when we simplify the inequality, you actually get it. You get equivalent inequalities. Our next problem is to use the definition to find the derivative. G of x equals 1 over x. Find the g prime x using the definition of the derivative. Okay. So step 1, you have to write down the definition first before you solve the problem. Right? The definition. H approaches 0, and the g of x plus h minus g of x divided by h. Okay, that's your thing. Then next step is to find a limit. But it's, of course, you can. You already know the derivative for using other formulas. You can find out the derivative. Okay, so you can put even the answer here on the side. So derivative, I know the derivative. The derivative is going to be negative 1 over x squared. Okay, using formula. Okay, by the product power rule. Yeah. So we know the answer. So let's see if we can get the same answer using the definition. We ask you to find the limit. So this problem actually is a limit problem. Okay, it's not about the derivatives. We use derivatives to check your ability to find the limit. Okay, I'm not asking you to find a derivative, basically. Main focus is 80%. Yeah, 80% of the problem is about limit. Okay. So we have to understand what is x plus h means. There are some students still don't know what does that mean, g of x plus h. And that's why there's some problems on the SAT math part. You will see that if g of x is 1 of x, what is g of x plus h, right? Then you just need to replace x plus h plus h. Okay, so this part should be correct. There are a number of students did not write correct, so they did not know what is g of x plus h. You have to replace x by x plus h. Okay. So if you then next step is to simplify. The first part is just the concept. Okay. What is g of x plus h? The next part is just simplify. Okay. So as I told you that this is the simplifying this expression is a good exercise for the 7th grade student. Okay, honestly, yeah, that's required a textbook. They should learn this. Okay, simplify this expression. Okay, so how to do that? Combine two terms in the numerator, right? And then x minus x plus h and divide by h. Okay, so you simplify. So this numerator is going to be x plus h, and x minus h is negative h. Okay, so it's a fraction over h. How do you simplify it? Well, fraction over h, then you divide by, multiply by 1 over h, right? Then h cancels out. Then the answer here is clearly when h approaches 0, you get x times x, which is negative 1 over x. So we knew the answer already, so we just need to verify this answer. Okay, so I can even give you the derivative, no problem. So avoid you give me the answer using other methods. I just wanted to prove that. Use the definition of limit. Use the definition of derivative to prove the limit as a derivative is negative 1 over x squared. Okay. Similarly, you can do square x. Okay. So you can do similar problems like 5. Okay. Y equals x cubed minus square x. Find the dy of dx. Now here's a problem. I look at one of the quiz problems. I noticed that the number of students, okay, just makes the problem very complicated. That use, okay, this is a quotient, right? They just apply the quotient rule to this problem to find the derivative. And it's very complicated. That's what I'm going to show you. It's so difficult to simplify. So okay, let's say derivative of this, the denominator square, right? No problem. Then you differentiate. This one be like a 3x squared, and then differentiate square x. Well, square x you can use a x to the 1/2. So it's like this. Then multiply denominator, then minus the derivative denominator, right? It's 1. Then you have to simplify this. So there's lots of terms there. It's not easy, right? To simplify. Okay. So yeah, you can simplify it now. More likely 50% chance to get the wrong answer. Okay, when you simplify this. Right? Yeah, it's not easy to simplify. So what you should do is you have to express, because the term in the denominator is just one single power function. So you should express it as sum of a power function to avoid using quotient rule. Okay, so that would be x squared minus x to the negative 1/2, because 1/2 minus 1. If we express this in this form, the derivative is so simple. It's 2x minus negative 1/2, right? X to the negative 1/2 minus 1, negative 3 over 2. So the answer will be done. Just a few seconds to get the right answer. Simple, right? So you look at the quiz you did. And I can make the problem in many different ways. Like, for example, like a square x, right? And the x squared minus, for example, minus x to the 4th power. Okay. If you use a quotient rule, it's still very complicated. Okay. If you're not, then you get x2 minus 1/2. And here's x to the 4 minus 1/2. Right? Then you get x to the 3 over 2 minus 7 over 2. Yeah, x to the 7. Then you differentiate each power function. Okay? Then you will get the answer. Oh, sorry. Right? So this is the answer. There are some problems you do have to use a quotient rule, such like 1 cosine theta, 1 plus cosine theta divided by sine theta. Find the derivative. Okay. you have to use the quotient rule, right? If you don't want, then you have to memorize the formula. What is the derivative of cosecant theta? Because the function can be also written as 1 over sine theta, right? Plus cosine theta over sine theta. And just like same idea, right? Then you can cosecant theta plus cotangent theta. So you have to memorize the derivative of cosecant theta and cotangent theta. If you do, then fine. Just put the answer there, find the derivative. Okay. In general, younger people can memorize more formulas than me. Okay. And I only memorize the formula for the derivative of sine cosine. It's much easier to him. Okay. So I'm not going to use the derivative of cotangent theta, use the derivative of secant theta. Okay. Cosecant theta. So what I'm going to do is I use the original and I apply the quotient rule. It's going to be square 1 plus cosine theta sine theta minus 1 plus cosine theta sine theta prime. Okay. Then next step is to calculate each of them. The derivative of cosine theta is negative sine theta, and here's the cosine theta. All right. So let's simplify it. It is going to be sine square theta and a negative sine square theta negative cosine square theta is going to be negative 1. I think that's all we can get. Okay. So it's going to be negative 1 plus cosine theta. Is this a fine answer? Maybe not. Different students give me different answers. Okay. When you come out to the class and check the answer with another student, maybe your answer is different. But you can modify it. Okay, you can check that. How do you do that? Well, I can multiply the numerator by 1 minus cosine theta. Okay, so what do you get? The numerator. Numerator is 1 minus cosine square theta. Then here sine square theta. Then the 1 minus cosine. You find out the 1 minus cosine square theta is going to be sine square theta, right? So sine square canceled out. You will get this simple form. Okay? Yeah, this is the simplest form. Only one single function there. And chain rule. Okay. Chain rule. So here's a function, find the derivative using chain rule. Okay, this is the first one is a squared cosine a plus x squared. Find the dy dx. Okay, a is a constant. Well, that just if you already know enough, practice enough, that's chain rule, right? So but if you want to separate, introduce a variable, then it's gonna be y equals a squared cosine w. W is x, a squared plus a plus x squared. Then dy over dw is going to dy over dx. Right? Dy over dw is actually the derivative a cosine w. And this is a derivative of a plus x squared with respect to x. So it's going to be negative a sine w. And that'd be 2x. Okay. So we better to put 2x in front of that. And w is going to be a plus x squared. So that is this is a simple function. You can differentiate directly. Okay, a good example will be like that: y equals square root of 4 minus x squared. Find the derivative of y with respect to x. That's a typical example. Okay. Right, so you can solve the problem directly. It's a power function, right? So when you differentiate with respect to x, you differentiate the power function first. Then you have to differentiate the inside the function. Yes. Minus square. That's a square there, right? I don't know where it's gone. It's a square. All right. That's why I cannot get 100 points on the test. On this. So everybody has, is disabled in this, so that's somewhere a little bit. Okay. Even you can, now, for example, when I write the email, I mean I will not come tomorrow. I read it. I see I will not come tomorrow. But after send out, I look at the email again. Why is the not is missing? So I guess the brain, because you keep talking, we are not, but the eyes see that. But actually, it's nothing. That happened to you or not? Yeah, that's happened to me. Okay. Yeah, you believe you write down this, but it actually is not. All right, so the answer is going to be 1/2 4 minus x squared to the negative 1/2, and then that'll be negative 2x, and I canceled. I get negative x and 4 minus x squared to the negative 1/2. Right, so that's it. So sometimes you can write x here, 4 minus x squared, and put a square root. So this is a traditional notation. Radical is a traditional notation. It's not the best choice, but looks friendly. So we use it. But when doing the computation, we don't like radicals. It's hard, so we have to change it to the power function form. Okay. Okay, so the next problem. Okay, find the derivative y with respect to x. Here, x and y are related, very complicated. You cannot solve for y. No, can you solve for y? Yes, you can solve. It's a quadratic function. But then you have to get two solutions. But you're not going to use that because it involves radicals. Okay? You can, it's quadratic function in y. So y depends on x, you can two solutions. But we don't need that. Okay? If I change it to y squared to y cubed, then you're not able to use the quadratic formula to solve y. Okay? So what you do is you differentiate both sides with respect to x. Okay. Then in your mind, you should view y as a function of x. Yeah, don't forget that. So the first way is a product. It's a 3x squared y squared, and then 2x cubed y dy dx, because y is a function of x. And this one, you get dy over dx, x squared, and plus 2x and y. Okay, and the right hand side, it's going to be 3x squared. So that's it. It would be a good idea, if you apply product law, make sure you have two terms. You can draw two lines like that, so you get two terms. Right? Then you mark those terms containing the derivative. Yes. All right. So you get. Yes. Okay. So you get 2x cubed y plus x squared and dy dx. And then you have a 3x squared minus 2xy minus 3x squared y squared. Put all the terms move to the right hand side. Then finally you solve for x. All right. Yeah, here the derivative involves x and y. Okay, but if you for this particular problem, you can solve for y squared. I just want to give you the formula. Yeah, how do you get that, right? If this is a quadratic function in y variable, so x cubed y squared minus x cubed plus 1, right, equals 0. It's quadratic function. So you can write down the solution for y. So negative b squared plus minus b squared minus 4ac. So it's minus positive. Okay. So this is answer. Y has two possible values in terms of x. Then you have to differentiate each of them, right? But the derivative is very complicated. So I don't recommend you to do that. Fx is a sine x. Find the linearization ln x at a equals pi over 3. Okay, the so-called linearization, this will be, in fact, you should know that y equals ln x is an equation for the tangent line, equation of the tangent line at the point when x equals 3/2, and then f of 3 pi over pi over 3. Yeah. So this is actually is an equation of the tangent line. Okay. So in other words, if you are able to find the tangent equation of tangent line, you can find linearization of the function. In general, we are not going to get ln x using the tangent line, but I want you to understand the geometry meaning of this equation. So what we do is we just write down the formula for this at pi at a, right? And x minus pi over 3. Okay. So you write down that formula first. You write down that formula first before you do the computation. All right, so what you have to do is you find the derivative at least, right? The derivative is going to be cosine x. Okay, then you evaluate the value, evaluate the function at pi over 3. Sine pi over 3, sine 60 degrees can be square root of 3 over 2. That will be cosine pi over 3, which is 1/2. Then you plug them into the formula, you get a linear function. That's it. You don't need to modify, don't need to simplify. But very this problem 10 is about related rates. That's a difficult part. Okay, what is being pumped into an inverted conic tank at rate of 3 square cubic per minute? So that's called inverted conic tank. Okay, and the water is pumping into at 3 cubic meters per minute. So what is going inside? Draw the picture here, right? And yeah, okay, we are given. And the height is 8 meters. And the diameter on the top, 4 meters diameter. Find the rate at which water is rising when the height of the water is 4 meters. Okay, so this is a question. All right, can you set up? Yeah, give it 1 minute to think about it. Okay, this is a. I know that there will be some problems. Students have a problem to work out this. So you have to introduce the variables, right? So this is how fast the water level is rising. So how fast means this is a fixed point. If this is the h, we want to find out dh over dt. That's it. So I'll give you this hint. Right? H is the height, is the depth of water, right? From the bottom to the level, water level. Okay, that's called. Let's denote by h. This is a function of t. I'm pretty sure h function, yeah, h is a function of t. So when time passes, the h is getting larger, getting larger and larger, but it's slowing down because you only pump the water at the same speed, right? At the same rate. If you increase, another question is that how to pump water into the tank so that the rate of at which the water is rising at a constant rate. Then you have to pump more water, increase the rate of the water flowing into the tank. Okay. That's another problem. But let's do this one. Did you read the notes I discussed similar problems. Discussed similar problems before in the class. So you have to write down information you understand H. Right? I think a given information is the volume of the water. It's increasing, right? So the volume of the water, we know we are given the information. The derivative of the volume is going to be 3 cubic meters per minute. So V is the volume. Okay. How do I calculate the volume? If I know the radius, it's 1/3 pi r square h. The volume of the water is increasing at the rate of 3 cubic meters per minute. Why? Because you pump water into the tank at that rate. All right, but when you look at the formula, V depends on not only just height, also the radius. But the shape of the tank is already fixed. So when you change the height, you change the radius. Okay? It's not like they're independent variables. Those are the related variables. That's what we're talking about, related rates, right? So H and R is related. They're not independent variables. But in the formula for the volume, yes, V equals, for the cone, V equals 3 pi r squared times H divided by 3. So if you look at the picture here, right? Look at the picture here as a cross section, right? Cross section. This is a 2, the radius is 2. Here's 8. If this is R, then that is H. Okay? So this 2 similar triangles here, R and H, 2 similar triangles. R over 2 is going to be H over 8, right? So ratio of the corresponding sides is equal to the same number. So H, yeah, you can use it. You can use R equals quart of H. Okay, so now you can put it here. So V is going to be 1/3 pi, a quart of H squared times H. Okay. I think it's 48 H cubed. Yes. Okay. So the volume is related to the height of the water. So when the water increases, when the water level increases, then the volume increases. Okay. So what's the question? Question is find the rate at which water is rising when the height of water is 4 meters. So you just differentiate both sides with respect to t. Okay, so that will be pi of 4/8 is 3 h squared dH dt. All right, now what do we know? We already know this side is 3. And here's 12, right? Or 16. Okay. So in order to find the rate of changing in the height, I needed to know the h. Okay. So that is going to be, again, it's going to be 3 times 16 again, it's pi and h squared, so 48 and pi h squared again, okay? So this is a general relationship. And when h is getting larger, the rate of changing h is getting smaller and smaller. So dh dt when h is going to be 4, right? When h is going to be 4, yeah, that is going to be 448 pi and 4 squared. I think this pi was 3. Right, that will be meter per minute. So we solve this problem. There are several problems, several type of problems for related rates. You should look at all the problems we discussed in the class, please. Okay, and yeah, let me give you an example. Okay, this is one of the problems. Yeah.
For this one, why did we take this R by T? Like when we were finding the H. I think it's,
Where's R?
we took it as R by 2 is equal to H by 8. So why did we take this by 2? Yeah.
You mean this one?
No. Like more, like when we started the question, yeah, the R by 2 is equal to H by 8. Why did we take it as 2?
Why take is 2? Because the diameter of the cone is 4, so the radius is 2. I just cut it. Yeah, I guess cutting. So you look at the triangle at the.
I took it as radius.
No, that's not radius. I just said the diameter is yeah, the diameter, not radius. Okay. Yeah, the geometry now required for this section is the similarity of triangles and the similarity of triangles and the Pythagorean theory. Okay. So let's do the one more problems. We know that let's consider just a rectangle. Okay. So this side the y, this is side x. Okay. and this is the length of the diagonal. So we know that the width is decreased by 1 meter per minute, okay, and the length is increased by 2 meters per minute. Okay, we want to find out how fast the length of the diagonal increased when x and y equals the given values. Okay, so find the rate of change in the well, use this notation. Let me use a dz. Okay, otherwise confused. Find the dz of dt when x equals 12 and y 12 meters and y is a 5 meters long. And this is the last problem. Please do this problem. So x and y are changing, so you cannot just assume they are constant. Before you find any derivative, don't give them a specific values. Do you solve it? No? It's a fraction, right? Anyone give me the number? Yeah, first of all, let's make an observation, right? When x equals 12, y equals 5, and this is a special triangle. By the Pythagorean theorem, x squared plus y squared is 12 squared plus 5 squared, which is 13. Okay. I memorized a few special right triangles. 3, 4, 5, like then 5, 12, 13. Yeah, you can list 7 maybe. Those are special triangles with the integer length. Okay, so that's okay. That's at this moment. But z is a function of t. Okay. Otherwise, if z is already 13, the derivative is going to be 0, right? It's not a constant. Just at that moment, I say when x equals 12. I don't know the exact time. I know both x, y, z always depends on time t, but z depends x and y. X and y depend on t. Okay. So in general, you have this is what you should know, right? In general, you have this relationship, right? So to find a derivative, in general, you have this, right? So find the derivative with respect to t, applying the quotient, applying the chain rule. This is -1/2 and the 2x dx dt plus 2y dy dt. Okay. Then you cancel 2. I simplify a little bit. You can put it back here. It's going to be square root of x squared plus y squared, x dx dt. This is a general formula, right? And you already know the derivative. So now, when x equals 12, y equals 5, at that moment, the derivative becomes here 12 squared, 5 squared, 13. Here's 12. What is the dx dt? Dx dt is going to be 2 and the 5, and dy dt is going to be the derivative y with respect to t is -1. Yeah, -1. So simplify, it's going to be 13, 24 minus 5. So it's going to be 19 over 13. That's meters per minute. That. Again, let me say, you should know Pythagorean theory and know how to use it. Another one is similarity of triangles for this course.